All right, guys, welcome back. I hope you are all safe and well. All right, here's the first announcement of the semester. Bow! Start the semester off strong. A second announcement. More exclamation points. And what about that one? Yes. And how are you? I hope you are well. I hope to see you guys in person next week. All right, here we go. Matrices. All right, we are starting to study the matrix unit 5, adding, subtracting, multiplying matrices. So let me write that real quick. The matrix. Guys, a matrix is just a fancy term for an array of numbers pretty much organized into a box. All right, so you have a hard bracket, another hard bracket, and then you have numbers arranged by rows and columns. So this particular matrix I just drawn in red has 2 rows, 2 columns. You number the rows starting at the top. So of course you have row 1, row 2, row 3, etc. And then you start with the first column and you work your way to the right. And each matrix has a bunch of what are called entries or elements. Okay, if you're speaking to a person who's doing more mathematical theory, they call them elements. Yeah. All right, so we discussed entries of a matrix, also called elements. It is important that you know the dimensions of a matrix, okay? You discuss or you define the dimensions of a matrix in terms of rows and then columns. So for example, matrix A has 3 rows, 2 columns. So you say the dimensions are 3 by 2. All right. Matrix 1B, 1 row, 4 columns. It's a 1 by 4 matrix. And then matrix C, which has algebra. Yes, we will be solving matrix equations and solving systems of equations using matrices. Fun stuff. 2 rows, 4 columns. This one is 2 by 4. So pretty easy, but just know number of rows by number of columns, RC, R by C. All right, so here we want to find the entry or the element that is 3rd row, 1st column. So 3rd row, 3rd row, 1st column. The entry is 2. A13 is the element that's in the 1st row. There's only 1 row. 1st row, 3rd column. That element is 3. And then 2-1, 2nd row, 1st column would be 3Z. 2nd row, 1st column. And then the 1st row, 2nd column would be X. So just to kind of differentiate, put those side by side, 2-1 versus 1-2. So of course the order matters. Okay, a few other details before we start actually operating on matrices. The identity matrices, an identity matrix behaves like the number 1. We're going to see that, but if you multiply a matrix by an identity matrix, you get the same matrix back, just like if you multiply a number by 1, you get the same matrix back. All right, so you have the identity matrix that is a 2 by 2. Identity matrices have to be square, meaning that the number of rows and the number of columns have to be the same. So all identity matrices are square. Okay? So you have one diagonal of 1s and every other entry or element is a 0. Just to kind of bring that home, let's look at this. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. That's the 4 by 4 identity matrix. Once again, it's a square, 4 rows, 4 columns, 1 diagonal of 1s and a whole lot of zeros. We'll see why this matrix behaves like the number 1. A 0 matrix, pretty easy. 0 behaves just like it does in the real number system. If you add 0 to a number, you get the same number back. So if you add a bunch of zeros to a matrix, you get the same matrix back, and we're going to see what that means. But a 0 matrix that's 3 by 2, 3 by 2, that is the 0 matrix. Very fast. It's just fascinating, I know. And then we have a 1 by 4, 0 matrix. 1, 2, 3, 4. Ooh, man. Fascinating. All right, so those are the details. Let's get into the operations. All right, our first operation is called scalar multiplication. Your multiplying matrices is tricky, but scalar multiplication, really basic. Adding and subtracting, very basic. So we'll spend most of our time on the multiplication toward the end of the lesson, but for now, scalar multiplication is simply multiplying all of the entries of a matrix by a scalar multiple on the outside. So you can think of it as distributing the scalar multiple. Right, if you're going to double the size of a triangle, then you multiply all of the corresponding parts by 2, kind of the same idea here. Okay, so if we want to double, we're going to multiply all of these entries inside the matrix by -2. So we get a new matrix of the same size, same dimensions. So -2 times 3 is -6. You guys can watch me make a mistake here. -2 times -1 is 2. -2 times -2 is 4. -2 times 5 is -10. -2 times 4, -8. Final answer. All right, scalar multiplication, pretty basic. Okay? All right, let's look at some more operations. All right, so now we're going to kind of mix it up a little bit. So if you look at number 4, part A plus 2B means you want to multiply matrix B by a scalar multiple of 2, then add the matrix to A, and I'm going to say we add matrices in the obvious way, and here's what I mean by that. So we're going to take matrix A, and we're going to add 2 times matrix B. Okay? So it really is like order of operations. Think of it as like parentheses. I need to do the scalar multiplication first. So 2 times all of those elements. 2 times 0 is 0. 2 times 4 is 8. 2 times 2 is 4. 2 times 3 is 6. And then once again, you add in what I call the obvious way. So you add the corresponding elements. So position 1, 1, you add to entry 1, 1. So 4 plus 0 is 4. -2 plus 8 is 6. 3 plus 4 is 7. And then 1 plus 6 is 7. Final answer. Boom. Okay, pretty basic. Okay, subtraction is going to work the same way. You subtract in the obvious way. So we'll do one quick example of that, and then I'll leave C to you. 1/2 B minus A means to multiply all of the elements of B by 1/2 and then subtract all the corresponding elements of matrix A. Pretty basic. All right, so part B, 3 times C, 2, 2x, 1, 0, 3, 4, minus 2 times E. E is 5, x 3, 0, 7, y plus 1. All right, so we do our scalar multiplication first. 6, 6x, 3, 0, 9, 12, minus. Now, here's where you have a couple choices. You can distribute the -2, and then it becomes addition, meaning you can change this to plus a negative, and you can distribute the -2. Or you can distribute the 2 and then subtract. I like to distribute the -2. Just makes it easier. So anytime you're subtracting, you can add the opposite and distribute a -1, for example, and we'll work through some of those examples. Pretty basic stuff. So -2 times all of this gives me -10, -2x, -6, 0, -2 times 7 is -14, -2 times y plus 1 is -2y minus 2. Okay, so we distributed the -2 to y plus 1, and this is all one entry right here. All right, then we add the corresponding parts like we did in the last example. So 6 and -10 is -4. 6x and -2x is 4x. 3 and -6 is -3. 0 and 0 is 0. 9 and -14, -5. And then it gets a little weird. 12 plus -2y minus 2. Let's do that off to the side. 12 plus -2y minus 2 is -2y. Combine your like terms. That gives me 10. So this last entry is -2y plus 10. Final answer. All right. Boom. Okay, so I'll leave you guys to try C, and you can ask about C. Okay, so now let's talk about multiplying matrices. All right, this is where it gets tricky. When you multiply matrices, okay, I'm going to show you the process. We'll talk a little bit more about the details, and then I'll run through 2 with you, and then I'll let you try 2 on your own. Okay, so when you multiply matrices, you multiply the rows of the first matrix by the columns of the second matrix. Meaning, you take the first row of the first matrix and you multiply the entries in the first column of the second matrix. It's always rows and columns, rows and columns. It's a little weird. Okay, so you actually multiply the 1 by 7, the 2 by 9, and the 3 by 11. Weird. Okay, so this is the actual work you're doing right here in the bubble. 1 times 7 is 7. 2 times 9, 18. 3 times 11, 33. Then you add those products together to get one entry in the new matrix. The new matrix is the product of the two matrices. It's very strange. Okay, let's try it again. So now we're going to do row 1 times column 2, and that entry is going to go here. All right, so here we go. 1 times 8, I'm going to do the work up above it. So we have 1 times 8. Then we have 2 times 10. And then we have 3 times 12. And then we add all of those together. So 1 times 8 is 8. 2 times 10 is 20. 3 times 12 is 36. Add those together. We get 28 plus 36. Oh, Lord, it's too early for this. 64. Boom. There it is. Okay. First row times second column goes in the first row, second column. That's your entry. All right, let's do it one more again. Let's make it purple this time. So we have second row. First column is going to go in the second row, first column. All right, let's do this and make it green this time. So we have 4 times 7. We'll do this off to the side. 4 times 7. 5 times 9. And then 6 times 11. 6 times 11. Then we add those products together, and that is our entry. So we have 28, 45, 66. If nothing else, like last semester we did a lot with fractions, you're going to be really good with your multiplication tables. All right, let's see if I can do this in a clever way. 28 plus 66 is the same as 30 and 64. So that's 94 plus the 45